Hello, my name is David Kelly. I'm a genetics research project coordinator here in ICBF in Tully. So we use the technology here as an ultrasound scanning machine. So the way this works is there's crystals inside this probe. When we pass electric current through those, they vibrate and emit sound waves. When we put that on the animal, the sound waves penetrate to the different tissues. Different tissues have different densities, so like fat, muscle, bone, and they build an image then on the screen. So we can use that image then to actually measure components of muscle and fat deposition and fat development on the live animal before we kill them. So we can get a really good picture of their carcass development before an animal is killed. That's particularly important for young breeding animals, and then also from a research perspective when we want to look at muscle and fat growth over time in live animals. We need a medium to pass for the sound waves to pass through. So we use oil as a medium on the skin. So we apply the oil to different scanning sites. So we have on the rump, which is kind of over or around. We look across the ribs, across the vertebrae for our kind of steak cuts, and then across the ribeye. So where we scan on the animal is the most valuable part of the carcass. So that's where most of the carcass value comes from, and that's where we scan the animals in real time. So the technology used here, this is an IMV machine. So the first thing we do is we input the tag number of the animals so we can actually trace back the images to the individual animals. So one thing for scanning is we have to remove any dirt or debris that's going to cause artifacts or blemishes on the images, so we get a really good clear image. So we clean the animal down, and then we apply oil then as a medium then so that the sound waves can pass through into the skin. So that's the probe here. You can see that's the contact area. So when we put that on the animal, we can build a picture then. And so I can see the picture on the screen directly. And from that then I can take the measurements. So that's our first location. Our second location that we focus on is across the vertebrae. So this is where your sirloin steaks come from. So we scan here and we're interested in the muscle and fat depth here. So we take the depth of the muscle, and then we can actually take a measurement of the fat as well. And then one of the third locations then is across the ribs. So here we're actually interested in the marbling of the animal. So we can get a really good picture here from the actual how much marbling is in the meat. That's quite a good indicator before an animal is killed, because oftentimes it's difficult to collect that unless the animal is quartered in the factory, but we can get a good indicator of the marbling before an animal is killed. In other jurisdictions, other countries, that's a really valuable indicator for their pricing system. While another trait that's of really interest and is very related to red meat yield is actually eye muscle area or ribeye area. So we use this thing called the gel probe. So what this does is actually follows the curvature of the animal. So if you look at the probe, it's flat, so it's quite handy for just going on a flat surface. But if you see in the animal on this ball here, you see the muscle, the ribeye follows a kind of curvature shape. So we use a probe that follows that curvature, so we can get a really good contact with the skin then from that. So I put the probe into the gel pad, make sure it's pressed in, and I can place that between the ribs, and we can get a good picture then of the actual ribeye of the animal. So those locations in terms of like fat depth across the rump, fat depth across the sirloin and muscle depth, and then eye muscle area, they're really good indicators for the actual retail yield of beef when the animal is killed. So they're very good indicators in terms for research, in terms of tracking muscle and fat growth over time, but also as an early life indicator to improve the reliability of our evaluations, particularly as we're measuring these traits on young animals that are related to bulls that are going to be widely used in the herd. So we can quickly get the benefit from measuring these animals out to the national herd quite quickly through genotyping.